Okay, so today we're going to start off with secondary air injection. Secondary air meaning air other than the air that was going through the intake system. And this air is going to be injected into the exhaust system. So this is what was commonly known back in the 60s as a smog pump, which is kind of funny because we injected air to get rid of smog, but the air pump got nicknamed a smog pump because if you had that on your car, that meant you had those horrible, awful smog controls that were robbing your power. So the mechanical belt-driven pump was used pre-OBD2 and also in OBD2, but only with an electromagnetic clutch. So it looked like an AC compressor clutch on the front of it. And Mercedes is the one who did that up through 97. Our Pulsar system, which does not use a pump, is only used on pre-OBD2 vehicles because it can't be monitored for performance, turned on and off per se, the same way. And it never worked that great. It just helped a little bit. Toyota was probably the last manufacturer to use that up until 95. And we didn't see Pulsar come in really until the 80s. So that was a narrow window compared to mechanical pump that was first introduced in 1966. So keep in mind, air injection was the first thing we really used to try to reduce tailpipe emissions. Catalytic converters weren't installed on cars till 1975, so 9 years after we started using air injection. One of the common misconceptions of air injection is the air is being injected to the exhaust to dilute it. It is not. Oxygen is being injected into the exhaust to oxidize HC and CO. So those are the two gases that air injection helps control. And it does a reasonable job. My 87 pickup truck has air injection and a carburetor and no computer. And it has to pass at the same tailpipe emissions as the fuel injected model with a computer with a huge catalytic converter with multi-port fuel injection, computer controlled timing, and I have to pass at the same tailpipe level. And air injection is a big reason why it's able to do that. So air injection, depending on where it's injected, can have a huge impact on emissions. Today we use an electric air pump. So this was used on some late OBD1 or pre-OBD2 vehicles, about 1994. Corvette did it, Jaguar did it. And then we used it on OBD2 vehicles. And this is directly controlled by the powertrain control module. It is used only during the first few minutes of engine run operation. So where the mechanical air injection system and even the Pulsar system was designed to lower tailpipe emissions, electric air pump air injection is designed to heat up the catalytic converter. So what they'll do, because since we know we're running a richer mixture on startup, we're going to inject air into the exhaust before the catalytic converter, create oxidation, and that heat from oxidation allows the converter to warm up in 2 minutes or less. So unlike that 6 or 7 minutes they were talking about in the video yesterday, a big part of strategy in OBD2 vehicles is to get that cat lid off sooner. And there's a couple different ways they do that, one of which is with electric air pump. With direct injection, we no longer need the electric air pump because they're able to control the fuel a little differently to create the same effect by using post-injection. But so we've really kind of changed the purpose of air injection from lowering tailpipe emissions to warming up the catalytic converter. So all air injection system work on the principle of oxidation. So just like our oxidation converter, which oxidizes HC and CO, air injection is oxidizing HC and CO. So for belt-driven and pump air systems, this oxidation is used to help control HC and CO tailpipe emissions by turning them into H2O and CO2. For electric air pump air injection systems, this oxidation is used to generate heat to warm up the converter faster. It doesn't lower emissions due to overfueling while the pump is running, but once the pump is turned off, the converter is hot. So in other words, our net emissions, because we have to overfuel to put the extra fuel into the system, so we have something to burn. The net emissions after 2 minutes is the same, whether we have the air injection system or not. The difference is the next 3 to 5 minutes because now the converter's hot. So we have this whole system to basically lower 3 to 5 minutes of emissions. Remember what I said? We're really kind of trying to sharpen that down to a razor's edge as far as where we're looking at how are we going to get rid of these emissions here and there, as we're really looking to cut that down. And so here's a whole system, a whole strategy just designed to get a cat to light off 3 to 5 minutes sooner. That's pretty amazing. So our belt-driven pump type, air injection is belt-driven on later OBD1 and early OBD2 models, but only with electromagnetic clutch on the OBD2 models. I mentioned Mercedes. Primary purpose of the air injection on these vehicles is to reduce HC and CO emissions through oxidation, either in the exhaust manifold or in the cylinder head cold and into the catalytic converter hot. Air injection cannot be injected into the cylinder head or exhaust manifold if the vehicle is in closed loop, right? Because if I'm looking at the oxygen sensor and I pump a bunch of air in before the oxygen sensor, what are we going to do? We're going to say we're lean, we can't control fuel. So I can only send air injection up what we call upstream or up into the manifolds or cylinder head if I have a car that does not have an O2 sensor. So it worked great on 1966 vehicles. Or when the vehicle is cold and not in closed loop yet. Air cannot be injected in the exhaust system on deceleration, or a backfire will occur. So this used to be very common on earlier injection systems, that if a vacuum hose popped off a diverter valve, we called it a gulp valve at the time, it would inject air on deceleration, and carburetors on deceleration dump a whole bunch of gasoline into the engine. And so you had a lot of heat, a lot of fuel, and now we're going to put a lot of air in, and you would get a big bang, and it would take that oval muffler that looked like this into something that looked like this, and eventually open it up completely. It would just explode the mufflers off of cars. Very, very common back in the day. So here's our belt-driven pump housing. So this is a dry pump. There's no lubrication in it. The pump model that I just showed you right here is pretty universal. It's like one company made it and sold it to everyone from MG to Mercedes to Ford, or Nissan. They seem to really, there is a couple other little different designs, but almost universally look very, very similar. Had a couple different options on how the hoses could go onto them. So what this would do is it would pull air in. Air is drawn into the pump, and then it sweeps around and squeezes the air in and then pushes it out the exhaust port. And so these pumps, when you first put them in, will tend to make noise. They actually have a little piece of paper in there telling you to give it 500 miles to break in. Do not lubricate. These pumps can be tested. These pumps are based on volume and pressure. So I have a calibrated tool that I made that has a hole at one end of it, and the hole is a specific diameter. And when the engine is running and the pump is running, we measure how much back pressure is created as the pump volume is pushing air through that hole. Because all of our little valving in this, our little check valves, tend to be spring loaded. So I need enough pressure to open them up, and I need enough flow volume to keep them open in order for this system to work. So this system is about flow and pressure. And by pressure, I mean low pressure, 1 PSI. So we're not talking huge pressure out of this thing, but we're talking a fair amount of volume. So this is a very low pressure pump. New electric pumps will make almost 3 PSI at max, or not at max, but during a test. But these older ones are with specs 1 PSI. And it doesn't sound like much, but when they wear out, they won't make it. And on older vehicles, the reason why I have the tool is older vehicles, you look at it and it's connected, but is it really working to reduce emissions? So we would need to test it to see, is it actually putting out enough air for the system to function correctly so that it would reduce tailpipe emissions correctly. So that's something that we really don't do anymore. I used to make students build the tool to do it back a number of years ago when these cars were much more popular and we were testing everything before some rule changes. So our air injection pump, so it's belt driven. I have the pump, we have a fresh air coming in, and then I'm gonna have air coming out. So what emission or emissions does the belt driven air injection system help control?
CO and HC, number
CO and
three.
HC, number 3, you got it. Because we're oxidizing. Those are the only gases we can oxidize. So air injections check valves are used on all 3 types of systems to keep the hot exhaust gases from damaging the other air injection system components. Valves are opened by pressure and volume generated in the pump type air injection system. Valves are opened by vacuum in the exhaust and the pulse system. And the valves are prone to becoming corroded, resulting in exhaust leak or flow restriction. So here's a couple different check valves. So this is the side the air pump would be on. This is screwed onto the exhaust, and these are going to be made out of metal. And here we can see we have a reed style valve. So air would push this open. Here we have a spring diaphragm type valve that it would push open. Here's another type where we have a spring and a one-way valve. So the air will push this open. And that's why I say it's about pressure and volume. We need to overcome the spring. And once we overcome the spring, we need to be able to hold it open and flow air. So if I'm only able to make pressure with my thumb over it, but not make sufficient volume to keep this open, it's not going to flow. It's not going to work properly. So the other thing these do is because exhaust is hot, there's a rubber hose that's attached to the side going to plastic valves and other things that are not designed for heat. So what this check valve does is it keeps the exhaust from coming up into here when the air pump is not running or if the air pump is weak. So, or if the air is not being diverted in this particular direction. So it's real important that we seal off to keep exhaust out of these rubber hoses and plastic valves, but very easily open when we want to flow air in. And we use these on electric air injection systems also. GM on their V8 trucks with air injection early 2000s has a real problem with these because think about it, the system, electric air injections runs for about 2 minutes when you first start the car and then shuts off. When the car is first started and we're pulling air in the morning, is there usually a fair amount of humidity here? So basically we fill it up with water and then turn it off and we'll fill it up with water again tomorrow. So hard to believe they corrode, stick, have problems. So that's one of the issues we have with electric air injection systems, especially by the coast. And even here in Fallbrook, we get a lot of the coastal humidity and fog come in. Not so much fog, but marine layer. And a lot of humidity year round. And so again, you're starting it up, you're getting that moisture in there, then shutting it off, and that moisture just sits there. The older mechanical systems don't seem to have as much of an issue, but they will rust out. So here's an air injection check valve right here. So this is screwed on to the air injection manifold assembly that in this case screws onto the exhaust manifold. We see our TAC hose right here. See the rubber hose here is going to go to what's called a diverter valve that I'll show you, or an air switching valve that I'm going to show you next. And these do go bad and you replace them. They just unscrew off of here. You do want to use NICs when you put the new one on so you can get it off, because a lot of times these are really tight. So you need to make sure you hold this really well with a wrench while you put a wrench on here to make this one come off. These will also rust out on the back side or disintegrate sometimes. I've also had them where you can't get them off with a wrench, where you actually cut this off here so you can get an impact gun on it, hold this with a wrench, and then use an impact gun to try to get it off. That doesn't work, then you put some heat on it in an impact gun sooner or later, because what you don't want to do is damage this air injection manifold assembly, because most of them are currently made out of unobtainium. So this is one of those things you do not want to damage. These check valves are still sold at XYZ Auto Parts. They're readily available. But these air injection manifolds, like I said, you do not want to damage them. If you bend it a little bit, it's not a big deal. What you don't want to do is break it off or put in leaks. So the air switching valve or diverter valve keeps air from going to the wrong place. So there's 3 different places that we can send air. And they only go to each of those places one at a time. In other words, we never send air to 2 places at once. So the first place is upstream. So this is going to be upstream from the O2 sensor or in the exhaust system before it reaches the O2 sensor. So this can be in the cylinder head. It can be in the exhaust manifold. But it's going to be before the oxygen sensor. Then we have downstream, again, referring to the oxygen sensor. So this is where we inject air into the exhaust system after the front O2 sensor, normally directly into the converter or just in front of the converter. And this is only going to be used in closed loop operation. Upstream is only used in open loop operation or vehicles that don't have an O2 sensor. And then we have dump, and all systems have a dump. So air is dumped in the atmosphere or into the air cleaner assembly. This is done on deceleration or in closed loop operation on systems with no downstream capability. So we have upstream, downstream, and dump. Dump is where we're going to send it when we don't want it to go upstream or downstream. Not all cars are going to go downstream. So again, you have these different systems, how they're designed. We even have some cars that don't go upstream, right? So there's variations, but keep in mind, we're not going to send air 2 places at once. And we use a valve that controls that. So this right here is an air switching valve or diverter valve. And in this example, I have air coming in from the air pump. When there is no vacuum, then air is going to flow to the exhaust manifold. When vacuum is applied, it closes this and air is going to be diverted out through this internal muffler. So consequently, these would hook up many times to manifold vacuum. So when you're accelerating, we're dumping a lot of fuel, but we have very low manifold vacuum, so we're going to inject air. At cruise, we're going to have less manifold vacuum than idle, so we're going to inject air. But what happens at deceleration? Huge amounts of manifold vacuum when we first let off that throttle. So that 24 inches of mercury is enough to close this, right? Because when we let off the throttle, we get that just instant real high vacuum for a minute before it comes back down to normal. And so it's not any vacuum is going to close that. It's going to be over a certain amount. It's going to be over that idle vacuum. So we use this for closing it off on deceleration. So here is a little fancier one. As cars evolve, customers actually thought that they should be quieter, kind of crazy. I don't know, but I'd be willing to bet that 74 Broncos probably louder inside than the new 2021 Broncos are, just guessing. You're never quite sure, but yeah, our expectations from vehicles has changed over the years. And so here again, we have air injection coming in. I have a manifold vacuum. I have a diaphragm, and I have to the exhaust system. And in this case, I have a better muffler for the diverted air to keep it quieter. We're doing the same thing. It looks different, does the same thing. Now we're going to do things a little bit different. So now I have air coming in from the air pump. I have diverted air up here. I have air that goes to the exhaust manifold or going to the catalytic converter. So here's an air switching valve, and I can switch depend on one of 3 places. So upstream, downstream, or dump. We have a vacuum signal here, and we have to have another vacuum signal up here that we're just not seeing. From here, we can get more complicated, right? Because we started evolving, started putting these crazy computers in. So now let's look at this. Boy, that looks a whole lot worse, doesn't it? I got vacuum connections, electrical connections, but let's take a look. I have air coming in. And as I come down up here, I can go up here and look, and I can see I got, upstream, air going to the exhaust ports. Dump, air going to the air cleaner. There's a vacuum signal for that. Then I come over here, I have my pressure relief. I have a downstream to my catalytic converter. a vacuum line here, and an electrical connection. So we're still going the same 3 places. We've just put additional controls onto when we're going to go those places. So the system hasn't changed. How we're controlling it is changed. So when I'm working on these systems, it's about, upstream, downstream, and dump doesn't change. It's fixed. This is what it has to do. I can trace those hoses and figure out what those are. The next question is, who controls when we go upstream, downstream, or dump? Is it vacuum lines? Is it electrical? How does this system work, and when does it want to do what? And that's where you get into testing the controls. And that's why we have manuals, because I don't know how to test this one off the top of my head or the previous one off the top of my head. I know what it should do. I know what it shouldn't do. I know that it shouldn't send air upstream on a warm car because we're supposed to be using the O2 sensor, right? I mean, so there's things I know it shouldn't do because it breaks the rules. But as far as how the system precisely works, that's what I need a manual for. And that's why we have manuals. So here's a real life one instead of a picture. So my air injection pump is right here. This valve is bolted onto it. If I remember, I have air coming off of here. I have some other air coming off down underneath here. You see I've got vacuum lines, electrical connections, another electrical connection, another vacuum line. So what does this mean? I know where the valve is. I can see where it's supposed to go. If everything's going where it's supposed to, there's no reason to test anything. If something's not going to where it's supposed to, then I get the book out and find out what's tested. So if these are 2 wires, any bets that's a solenoid? Do we know how to test solenoids? Yeah, right. We need a power and a ground. Computer's going to control either the power or the ground. The other one's going to be there all the time. We've already learned about solenoids. So there's nothing new here. We're just applying it in a new way. Vacuum diaphragms. We've talked about vacuum diagrams going back, timing advance. We talked about vacuum diaphragm coming over spring pressure. EGR, we talked about vacuum diaphragms overcoming spring pressure. Is that any different than what we're doing here? No. These are all pieces of things you already know. We're just putting them together in a different way. Don't be intimidated by something you haven't worked on, because you have the foundation, you have the tools to gather the information you need and go, oh, that's a solenoid. Oh, that's a vacuum valve. Oh, that's a fill in the blank. And once we know what it is, we know how to test it. Or we talked a lot about power probes. Could I apply power to this in the correct polarity, energize the solenoid, and see if it changes where the air goes? Right? So when discussing air injection, the term upstream refers to injecting air into which location?
Before the O2 sensor.
Before the O2 sensor.
Number 1.
You got it. Specifically before the front O2 sensor. Absolutely. So air injection systems. So pulse air injection. Pulse air injection relies on the principle that there is high and low pressure events in the exhaust stream. And we've talked about this some. Those of you that saw the diagnosing misfire video, you saw the tool I put in the tailpipe to figure out what cylinder is misfiring. That works on the principle of the exhaust pulses, and you can see the waveform there. So that should be a good visual to what I'm talking about here. So during the high pressure events, the check valve is forced closed, preventing exhaust gas from entering the fresh air side of the air injection system. During low pressure events, the check valve is drawn open and fresh air is introduced into the exhaust system. System is very simple with very few parts. Needs additional controls if it is used with a feedback system. So Toyota system, which used an O2 sensor, had additional controls in it on their trucks. So here's a very early, this is 1980s, General Motors has a air injection system that's screwed into the exhaust manifold, and it had a box with 4 reed valves in it. And each time there was a low pressure event, it would pull a small amount of air into that manifold. These boxes would rust out, go away, and I don't know if there's even one of these on the road still. These were used by like Chevy Citations, Cavaliers, circa 1980s. I think they're all dead. Every time I say that, I see one on the road. But old, but again, it's technology. Here's Toyota. This is a little later. Pulse air system. In this case, all the passages are inside the head. You have a hose going to a check valve going to the air cleaner. Pretty simple system. Here is a later Toyota. This is about 1990. Here we're using vacuum to turn the pulse air system on and off. A little more control. It's a computer controlled system, so we want to be able to turn it off so we could use the O2 sensor. So we use a solenoid, switch vacuum, now we turn it off. So again, this is an old system. You may see some of these because again, these were used. I mean, there's still, 90 series 4Runners and Toyota pickup trucks running around that have air injection on it, especially with the 3-liter motor, which used air injection. And there are still some, late 80s vehicles, carbureted Toyotas and other stuff running around out there. Occasionally we still see them. So I even entered early 90s carbureted Toyota. 91. So pulse air injection systems are used on OBD2 vehicles. Is that true or false?
False.
It is false. This is a pre-OBD2 system only. I got to get in the Wayback Machine to go look at this. So let's look at modern vehicles. Our electric pump type system, directly controlled by the powertrain control module, only used on cold start for the first few minutes of engine operation to help lower HCO emissions cold, but the primary purpose of secondary air is to warm up the catalytic converter. When HCO are oxidized, heat is generated. The increased exhaust heat allows the converter to light off in as little as 1 or 2 minutes. So if you have one of these systems, it probably sounds like someone turned a vacuum cleaner on underneath your hood when you first start the car, because some of these are fairly loud. And that's really what it is. It's just a little round air pump. So here's the air pump right here. This happens to be a Saturn. So here's an air pump right here. It has a hose going to a air control valve. And so here we have a vacuum source that opens the air control valve, and this takes the place of a mechanical check valve. Pretty simple system. And this system is monitored and will set a code if it doesn't work right. So there's actually a performance where they inject air into the engine and evaluate if the volume of air being injected is sufficient. For General Motors, what they will do is they will do this on a warm engine and then inject air and look for the O2 sensor to go below 30 millivolts. In other words, is there a lot of air in the exhaust? So if it can't go below 30 millivolts, we're not flowing enough air, we set a code for low flow. So that's the logic GM uses. Other manufacturers get way more high tech. So here's BMW. BMW has a mass airflow sensor here. And so they measure the amount of air coming in, equate it to the amount of fuel trim being shifted, and calculate the grams of air that are being offset to see if it's the right amount or not. Porsche does something similar. So again, GM, very simple. Does the O2 sensor voltage go low? Porsche, BMW. How many grams were actually offset? Let's do a whole bunch of math here. And I mean, we're doing the same thing. We're testing the system, but boy, one is way more overcomplicated. But this is, and these little mass airflow sensors will set their own code. And then the air injection system, it comes through here, pump, and then it connects to the manifolds on the BMW. So you can see these are a pretty good sized pump. That's why I say they make noise. They kind of sound like a little vacuum cleaner going. And you only hear that the first minute or two. Not all of them are easily accessible. Here is Toyota. So this is a 4.7 liter Toyota where we put the air injection pump underneath the intake manifold. So I've removed the intake manifold here. We have the pump, a control valve, and then it comes from here over to these two switching valves right here. And these switching valves go bad. What happens is the filter for the pump comes apart goes into the pump, breaks the little plastic. The little plastic pieces go out. They usually make it through this valve and they get stuck in these valves. So from this point right here, it's another 2 hours to change these valves. They are not easy. But on the bright side, it's like a 7-hour job between the 5 hours to get to here plus the time to get to there. Here's our starter right here. So you got to pull the intake manifold off to do a starter and take this off and pull this off. You got to take the air pump off and this off just to get the starter out. So again, not all starters are easily accessible either. But this was real common. Did quite a few of these. And that's how I know how much time is involved to do what. This was high failure for a while. Here is, again, electric air injection. Here's a close-up of an air switching valve. So I have exhaust here. I have cool air here coming from the pump, and then I have the control valve right here. So instead of using a mechanical check valve, they're using a computer controlled switching valve. Just more precise control. And one reason for this is testing. We want to be able to test the system, and different manufacturers have different ways they're going to do that, but they have to be able to test the system for flow. So the purpose of the electric air injection pump system is to perform which of the following tasks?
Warm up the converter.
Warm up the converter, number 4. And this is a good example of a multiple guess question because I put lower HC and lower CO on different lines. So since it affects both of them equally, neither one of them can be their answer that's being looked for. Therefore, it takes you down to warm up the converter. Because if you picked 1 or 2, you're saying, well, gee, it oxidizes HC, but it doesn't oxidize CO. That's wrong.
I was confused a little earlier because number 1 and 2 seems to be also like the purpose of the air injection, but it goes also with the warm up the converter. So I wasn't sure whether 1, 2, 4 would be the answer.
Right. And that's why I specified electric air injection, because on old mechanical air injection, it's there to lower HC and CO emissions. Electric air injection is to warm up the converter. And the reason being, the reason why it doesn't really lower those emissions per se while it's running is that we overfuel. So where we might have a flat line of emissions on a car without air injection, we're going to overfuel. We're going to have higher emissions for about the first minute, and then it warms up, and the next minute we have lower emissions. So the total emissions for the first 2 minutes is about the same as if we had no air injection at all. And so there's no net improvement on emissions for the first 2 minutes of operation using the air injection pump because we're adding extra fuel in order to get that oxidation to light up the catalytic converter. So we lower emissions actually after we shut the air injection off. That's when emissions are lower, and it's lowered because the cat's hot. Does that help, Cynthia?
Yes, sir.
Okay, good.
Yeah.
So my ignition spark controls. So we talked about this already some in ignition systems. So this is going to kind of be a review, both on what it does and also what we're looking for when someone does a smog inspection. So ignition spark controls are used as a compromise between maximum engine performance and acceptable exhaust emissions. As timing is advanced, engine performance increases, but so do HC and NOx emissions. The timing must be advanced for performance, but only until exhaust emissions increase above acceptable levels. On emission control vehicles, both mechanical and electronic timing controls are used, depending on the age and vintage of the vehicle and the technology. So here is a mechanical timing system. So here I have vacuum advance. There's going to be centrifugal advance down inside here. I have a vacuum line that comes over to a thermal vacuum switch, and the thermal vacuum switch goes off and feeds other components. Again, pre-computer. So I'm going to have different advanced cold than I will hot. I may want, if my car starts overheating, I'll actually retard the timing on a little bit. So we do that. So you've heard me talk about the heat events. So this is where I put the little animation slide for talking about the heat events and why controlling time in advance is so important and why over advancing causes a problem. So I've got the beginning of the compression stroke, the end of the power stroke, and TDC. So I've got one crankshaft revolution from bottom dead center to bottom dead center. And so we have the intake valve closing, and then my base ignition timing on my theoretical engine is at 10 degrees before top dead center. I have maximum pressure from compression is going to be slightly after top dead center because the molecules are still moving from the piston, pushing everything together. And my maximum pressure from combustion is going to be about 16 to 21 degrees after top dead center. Again, based on engine design, based on things, this is where my theoretical engine wants to be. So I have time between these two heat events. But look what happens if I over advance my timing by 5 degrees. So now I'm at 15 degrees. So is it going to move at 15 degrees here? Or is it going to move at more than 15 degrees there? Or less than 15 degrees? What do you think? In other words, I'm moving 5 degrees here. Is that same 5 degrees here? Or does it change on this side compared to this side?
Change more.
It changes. Yeah, and it's going to be a bigger impact because keep in mind, my piston's going up. We have a smaller chamber. As we're burning the fuel expands, and I would hit my maximum heat event at 16 to 21 degrees after top dead center. Well, if I start sooner, the flame is expanding sooner, I'm going to reach that maximum expansion and pressure, heat pressure, much further up because I've less area I'm filling. Does that make everyone following what I'm saying there?
It's because of the heat and the fuel expands. That's why the degree of change is more on that side.
Right, because the fuel's expanding, but it has less area to expanding because the piston's not as far down. So therefore, it's going to be an exponential increase. And so as that increases, now it gets too close. And we have excessive heat, which makes NOx. So what's interesting about ignition timing is this is what makes NOx. What makes the hydrocarbons is similar to this, but it's more about igniting the fuel too soon, and we don't get a good burn out of it. And what happens, we leave unburned fuel because we don't have good fuel propagation. The excessive heat is what makes the NOx, but we are going to get some hydrocarbons out of it also. But this is interesting because normally we see HC and CO. If something affects HC, it affects CO. I mean, we normally see those two tied together. Ignition timing does not do that. Ignition timing puts NOx with HC, and this is the only system that is used to control NOx and HC. Because all the other systems control either NOx or they like EGR does, or they control HC and CO like air injection does. So this is a unique pairing of these two emissions that how spark control affects them. So hopefully this little animation I put together helps a little bit. So here is a dual diaphragm distributor. So we saw the initial diaphragm distributor. We talked about that in ignition where we advance. On a dual diaphragm distributor, we will actually retard and advance the timing. So I may want to retard the timing at idle, but advance the timing at cruise. So I would hook manifold vacuum up to the retarded side and the port vacuum to the advanced side. So that way manifold vacuum would pull it this way, retarding the ignition timing, and port vacuum would pull it this way, advancing the ignition timing. So we saw this on later vehicles. You're talking late 80s into the 90s is when we saw dual diaphragm or even 3 diaphragm vacuum advance units in the case of Toyota. We'd also have other switching valves on systems. So this is a switching valve for manifold vacuum and porta vacuum to the distributed advance unit. Again, we did a lot of stuff before we had computers. Coolant override switch, so ported vacuum for from the hot switch, or manifold vacuum from the cold switch. You see the reverse. So this actually goes with two other thermal switches. So instead of having a computer, you had a hot switch, a cold switch, and then a switching switch. So you had three switches all together with a bunch of vacuum lines plugged together. Remember when I said cars are much better now? Here's a vacuum solenoid. This was part of our transmission controlled spark system that would only allow spark advance in certain gears and would be locked out by the solenoid. And this always got interesting when a shop put the wrong transmission in a vehicle and it no longer had the switch on the transmission for the computer control spark. For the transmission control spark. So I failed a couple cars over the years because someone put the wrong transmission back in. And now their transmission control spark system wouldn't work. So this is 70s technology, this really old stuff. I keep the picture because transmission control spark kind of interesting when you think about we're only going to allow advance in certain gears, but also this foam filter. And what do you think the odds of 40 years this foam filter is still there? So, and that goes back to my discussion I had yesterday about just because there's a port with nothing on it doesn't mean there's supposed to be something on it. That's why we have vacuum diagrams, just like we have electrical diagrams, we have vacuum diagrams that show us how things are supposed to be hooked up. So things get hooked up correctly and only how they're supposed to be hooked up. So we don't guess. Here is a spark delay valve. And we talked about these a little bit already. This is a directional valve. And so in this case, I have ported vacuum and a distributor, but we use these for EGR. We use these for all kinds of things to solve drivability problems. I got a picture coming up on a car, I think with 5 of them. Again, pre-computer controlled. Oh, the EGR is opening too fast, put a delay valve in it, right? So we solved a lot of issues with this. These are color coded. They'll be black on one side and have another color on another. So they might be yellow, blue, white, and so on. If you're replacing them, pay attention to what direction they go and pay attention to what color. You don't change colors. If you got a yellow and black one, it gets a yellow and black one put back in, because that has to do with the amount of delay, size of the orifice, those kinds of things.
Sir Brian?
Yes.
What is the sintered orifice?
What is the what?
Sintered orifice, the one on top.
This. It's just an orifice. I don't know why they put centered there.
Oh, okay.
But it restricts and it has a little diaphragm. So it works, and you got a check valve on this side. So it restricts it going one way. So it can only go one way, but then it also limits the movement because it has to have a way of coming back. So what it does is it restricts it going one way, but allows it to come back the other way without a problem, kind of like a check valve. So that's why you have the check valve here, and you have the orifice. So the orifice goes one way, and then the check valve opens up when you release.
Okay, thank you.
So an example would be here. Here's another, this is called an OSAC valve that was used by Chrysler up to 81 to reduce NOx. But this valve, same kind of thing, just a lot more complicated. But it delayed vacuum to the distributor by 17 seconds. But when you let off and we wanted the timing to go away, it would release it like that. So that's what these delay valves do, is they limit, they restrict how quickly vacuum is going to get there. But when we don't want it there anymore, they quickly let them go away. And that's why you saw the two valves inside here of the centered orifice and the check valve. Because one way we're forced to go through the orifice, the other way the check valve opens and just dumps everything out. This is our orifice spark advance control. So ignition spark controls. What emissions are spark timing controls used to help control? There's a mouthful.
NOx and HC.
NOx and HC, number 5.
Sir Brian, is there an easy way to remember what system controls what? Because there's so
Uh,
many of them.
yeah, there is some, some things help me remember, like air injection. I'm oxidizing air injection. So therefore, an oxidation converter, air injection, both works HC and CO because we're oxidizing. So the chemistry helps me there. Spark controls is a hard one because it's an unusual combination of NOx and HC. It's the only system that combines those. EGR is NOx only, so that's just simple memorization. But again, we're using EGR to what? Lower the heat in the combustion chamber. What's NOx? Excessive heat. So that helps some. But no, some of it is kind of memorization, unfortunately. The tricks that I've used over the years to kind of help you, I've shared. Just like things either benefit NOx or they benefit HC and CO. The only exception to that is a three-way Cala converter that does all three, and ignition spark controls that does NOx and HC. Other than that, HC and CO are always paired, and NOx is by itself. So, I mean, that kind of helps when you're answering a multiple guess question if you're not sure. So, so that's, like I said, but that's why it's important to remember that ignition timing is kind of the outlier. It has a weird combination. So I don't have a silver bullet for you, Cynthia. Sorry.
Okay, but thank you. That's a good thing, like good things to remember. Like the EGR is NOx only, and all the others are mainly CO and HC.
Yeah, and one way of looking at it also is remember your definition. CO is a lack of oxygen. HC is unburned fuel. NOx is excessive heat. So as we think about those definitions and think about how these systems work, we can see why they affect one emission or another. Like PCV is there for HC emissions. Well, HC is unburned fuel. Hydrocarbons. Well, what's oil? Oil is a hydrocarbon, right? So hydrocarbon vapor, gasoline vapor, hydrocarbon. So it kind of makes sense when we go back to those definitions I gave you also. So we use an other emission related components category during the smog inspection to kind of capture all of the systems that we call not major systems, or systems that were rarely used, sometimes used. And manufacturers are constantly inventing new systems for controlling emissions, and there are several old systems that were tried and no longer used. So this is kind of a catch-all. This category is also used for emission systems not widely used, and category is used to identify them on a visual inspection during the smog. So one of the things that I need to do for a smog inspection is I need to verify my vacuum hose routing. So this is why smogging in a mid-80s Toyota like I have here takes much longer than smogging a 2015 Toyota, because a 2015 Toyota doesn't have a gazillion vacuum lines on it. Now, as I look at the vacuum lines, you can see I have a vacuum delay valve right here. See the yellow and black like I was talking about. And we can see my EGR valve right here. There's my EGR valve. Comes up to my EGR back pressure transducer that's getting the two vacuum signals from it on Toyota. So we can see here, not only do I have a back pressure transducer, but we still put a delay valve in going to the EGR for drivability on this system. So you can see, but imagine having to trace each of these down to make sure they're all connected correctly. So on a system that looks original like this, I'm doing some quick cursory checks. I'm not probably checking that every one of these is hooked up exactly right and tracing every one to its end, because it really looks factory. Things look like they're in the right place, hasn't been messed with. I'm going to check my major systems. But is it possible someone got something by me? Yeah, it's possible. Now, someone goes to XYZ Auto Parts and buys brand new vacuum line, or buys some really neat yellow vacuum line or red vacuum line because they're in high school auto shop. I will take the time and trace every one of these to make sure they're correct, because someone's been there. You follow the logic there? If it hasn't been touched in 20 years, it's probably still in the right place. If someone's just touched it, what are the odds they made a mistake? Pretty high. And here's, you can see our TAC kind of off here on the side. Here's our vacuum motor And there's our TAC tube right there. So underneath the hood, older cars had a vacuum schematic. So our vacuum schematic is going to tell me where the front of the vehicle is. It shows me the air cleaner. So here's my TAC system, our thermal vacuum switching valve, and my vacuum motor. Shows where it hooks up to which port on the carburetor. Tells me I have a 4-barrel carburetor because there's 4 barrels basically, or 4 ports for air to come down. Here I have what? My EGR solenoid and EGR. I have a vacuum sensor for the computer. That would be, a map sensor. Is that what we call vacuum sensors? Map sensors. Come over here, and I come over here to a purge thermal vacuum switching valve. So over here to here to here. And here's my fuel evaporation canister to my fuel tank. Here's a check valve, and I have a couple other vacuum sources here. So this is all going to be done through the canister control valve. I have an EFE here, which gets manifold vacuum, or which is going to be split right here. Part of it goes to air injection through a check valve. Part of it goes to EFE. EFE stands for early fuel evaporation. And that is kind of a misnomer because it has nothing to do with our fuel evaporation system. What it is it activates a door or a flap in the exhaust to push exhaust or actually restrict exhaust to heat the exhaust manifold and in turn heat the intake manifold. So on a V engine, they'll have a crossover that goes from one bank to the other. So if I plug up the exhaust on this side, it forces exhaust through the intake manifold and out the other side cold, which heats up that big cast iron intake manifold. So as gasoline is going through the carburetor or through the throttle body fuel injection, that gasoline is hitting that cast iron manifold, that aluminum manifold. Instead of that manifold being really cold because we just started the car, it's getting hot very quick because of exhaust circulating through it. So that helps vaporize the fuel. Hence the term fuel evaporation. They're evaporating the fuel in the intake manifold. It's a horrible name for the system. Should be like a fuel atomization system, fuel preheat system. So there's a little, they call them a heat riser on the exhaust, and some of them are just spring loaded with a spring. That was actually used because the reason why there's only one on one side, it was actually used to force exhaust either through the V on a V engine or hold exhaust. It was a straight 6 engine. It was used because the intake manifold bolted directly to the exhaust manifold and the carburetor sat directly above that. So that heat riser would hold the heat in to heat this manifold, which would heat this manifold, which would allow for better fuel vaporization. And so that heat riser was actually an emission control device. It also helped a lot with drivability. Cars ran a lot better cold with that heat riser there, because otherwise you really have to let the car warm up 5 to 10 minutes or longer, depending on the climate, before the car was not going to stall as soon as you try to go to a stop sign or try to accelerate, because the fuel was just turning back into liquid and not burning. So that's what that EFE is. So here is a system, a little more complicated. Still tells me where the front of the vehicle is. Still tells me where it has a carburetor. EGR is right behind the carburetor. I got some air cleaner valves here. Must be for TAC. Purge, I recognize that. Hey, here's our distributor we just looked at. Here's that thermal vacuum switching valve, the yellow one that we just looked at in the picture. And I come back through here and look at the delay valves. Delay valve, delay valve, delay valve, delay valve. You think we used a lot of these to kind of solve problems? Right? Again, we didn't have computers. This is a pre-computer system. So if something's not working right, what do we need to do? Oh, we need to delay it a little bit. We need to get it faster. So we did, we don't want this cold, or we don't want it below a certain temperature, or above a certain temperature. So we had to use these thermal valves and delay valves and switching valves to make all this magic happen. You know, the bad part about these systems is there's nothing to plug a scan tool into. So if the thing's not running right, you're down to just testing things. And that's why it's important to understand the relationship between the emissions and the systems, because based on the emissions that I might be exceeding state standards on tells me which systems I need to concentrate on diagnosing. So we look for vacuum line connections. So I think this is an aftermarket install of a bolt into a vacuum hose. Uh, so the question is, should this have a cap here, or was this supposed to go somewhere? I don't know. I would need to go to a vacuum schematic and find out. Here's a thermal vacuum switching valve. I mentioned before, these are all color coded. So this has 2 ports and a vent. And that has a pipe thread here. And I don't want to put a different color there because it will not work the same way. So I would need a black 2-port, actually 3-port with a vent, but the vent needs to be on the bottom. So we would match this configuration and this color and this thread size, and that gets me to the right valve. I'm not going to put a yellow in or a blue in because that changes the temperature they're calibrated for. So part of smog inspection, we're always looking at electrical and vacuum connections. Obviously, this is much easier for me to check because this is a molded connector. It only goes in one way. If all that's gone and someone's run fancy red vacuum lines, it's going to take me a lot longer to look at it. But this only goes one way. So if it's plugged in, it's pretty good. Where does the other end go? So part is looking at our electrical connection. So here's a vehicle. This happens to be an electrical connection that failed on a vehicle I was inspecting and repairing. The ironic thing is this part was just put on by another shop. And the car came back and they thought that just zip tying up the melted wires would be okay. The sad thing is they charged the customer $1,500 to try to fix their car that was failing smog, and the car failed worse. By the time I fixed the things the shop did, I got the car back to running the same as it was before the shop worked on it. In other words, failing by almost identical numbers. And then I was able to fix the car. But it was several $100s just to undo their $1,500 repair that was just either done incorrectly or had nothing to do with why the car is failing and actually made it run worse. And in that case, there's actually a customer that I helped them with the complaint form for the Bureau to file a complaint to get their money back because the shop wasn't licensed to do the smog repairs either. In California, only a licensed smog repair station can perform repairs, and those repairs must be performed by a licensed smog repair technician. Otherwise, it's actually against the law to take money for those repairs. So it's a really easy thing for the Bureau to come in. It's unlicensed activity. You need to give the money back. So here's an example of that EFE valve or heat riser that I was talking about. So it goes between the exhaust pipe, the exhaust manifold. This one, instead of having a bimetal spring, has a vacuum actuator, so the thermal switch is controlling it. Here's an older mechanical style heat riser, EFE. Has a bimetal spring here, like we used in our choke thermostat, and a little weight. And as it heats up, this opens. And it's counterweighted. And if you flow enough, like you floored it, you could actually force the spring open so the car wouldn't die on you per se. So you were able to force air past it. Turbochargers. Turbochargers are also considered an emission control component because they change the density of the air going in the engine. Same with superchargers. And it's the example here is a supercharger that was installed on a Corvette aftermarket company. So this is something the customer purchased and put on their vehicle. And this particular one is completely street legal because it has what's called an executive order number. In other words, the manufacturer spent the time and spent the money to install their component on a vehicle and send it off to the lab and have it tested for how it affects emissions on the vehicle. And it was found not to affect the emissions on the vehicle and therefore was certified as being approved to be installed on this vehicle. Keep in mind, executive orders are very specific. So very specific as to the part that's covered and very specific as to how it must be installed and very specific as to which vehicles it is allowed to be installed on. So just because something is approved for a 1996 Corvette doesn't mean it automatically is approved for a 97 Corvette. It depends on what the order number says. So all the arguments of, well, it's the same engine, or it's the same this, or it's the same that, doesn't matter. If the manufacturer didn't get it certified for that application, it's not legal. We see this a lot with air filters. We see this a lot with different things. Well, no, they didn't change it between the 96 and 97. Yeah, it's legal for 96, not 97, because the manufacturer never went back and got another executive order saying it is approved for 97. Therefore, it's not legal. And so we see things like that all the time. Because you can't just add years. You got to go back and redo the whole process, get a new number. And it's $10,000 to $20,000 to run it through the lab. So that's why a lot of these kind of manufacturers that either don't value the California market or they're really small time, don't do it. So here's our direct ozone reduction radiator that we talked about in cooling systems. And we have the DOR right here on my emission label. Yeah, there it is, DOR system. And we talked about this in cooling, the difference between the DOR and non-DOR system, the color of the core. Other emission-related components are also exhaust pipes, exhaust manifolds, up to the last emission control device. So the last emission control device in the exhaust system on a gasoline-powered vehicle will either be a rear catalytic converter or a rear O2 sensor. After that device, you can do anything you want with the exhaust system according to the Bureau of Automotive Repair. Now, you may get in trouble with noise ordinances if you know, that's a different story. But from an emission standpoint, we don't care what happens after the last emission control device. So that's where you see a lot of manufacturers now sell cat-back systems. So we were talking about dual exhaust, and the dual exhaust business really went away because of emission control requirements. There was a time when they allowed us to put dual exhaust on vehicles. And if it had a catalytic converter, we just had to put a catalytic converter on each side. That is no longer the case. And that hasn't been the case for over 20 years now. They changed it well over 20 years ago to where if it only had one catalytic converter from the factory, you can't change that. You're not allowed to change that. That is the sticking point. So that's why you saw these cat-back systems where they go from that single catalytic converter and give you two tailpipes. It's still a single exhaust system because everything's going through one cat. You just have two tailpipes. But that's where you see these cat-back systems marketed a lot. Equipment identification, primary source of the vehicle emission requirements is the underhood label. Second source is the ECS manual. Factory manuals or other published information can also be used. So there are two primary types of emission control labels: early 2007 and 8 and before, and the late 2007, 8 and after. On heavy duty vehicles over 8,500 gross vehicle weight rating will have their primary label attached to the engine. So here's an old style label. We have a vacuum schematic. Tells me this vehicle conforms to US EPA and California regulations. It's non-catalyst, has an EGR and an air pump, gives me my spark plug gap, and it gives me some other tune-up information. So quite a bit of information on this label. Here's an OBD2 vehicle with the old style label. Gee, I lost my vacuum schematic. Don't have much in the way of tune-up. I have information on valve adjustment and that no other adjustments are needed. It does give me my engine family, my engine size, my emission controls, tells me it's OBD2 certified, and it is a California vehicle. So again, giving me this information. Here's a heavy duty OBD1 label. In this case, it's a 2002 vehicle. OBD1 certified because it is over 14,000 pounds. OBD2 regulations only go to 14,000 pounds. And this, because it's OBD1 certified, it has to be a California vehicle. And it tells us that right here conforms to California regulations. So it gives me my engine size, engine family right here. That's my EVAP family, engine size, engine family, and emission control. So I'm still getting all this information, but you can see how different these labels can look. Here's a 2000 vehicle. This engine, first clue. So when the engine is certified, it's over 8,500 pounds. If it's the vehicle, it's going to be 85 and under. Oops. This engine is certified to EPA regulation applicable to the 2000 model year heavy duty engines and is certified for use in all heavy duty vehicles. No mention of California. No mention of OBD2. Gives me my engine size, my engine family, my emission controls, my spark plug gap. This is not an OBD2 vehicle. This is a federal non-OBD2 vehicle. It's not OBD1. It's just not OBD2. So then we have the new labels, which tend to give us less information, but I think are a little simpler to read. So here I have the US EPA standards it's built to and the California standards. It tells me it's an OBD2 vehicle powered by diesel fuel, 2014 model year, all of my emission controls and my engine family. So all in one simple place. Here is another one. Same thing, diesel 2011 model year, light duty truck, LDT. What was the previous one? Passenger car, PC. So this is an ultra low emission vehicle generation 2 passenger car. This is a low emission vehicle 2 light duty truck. So low emission vehicle generation 2 is not as high a standard as ultra low emission vehicle, right? I mean, ultra low sounds like it's much cleaner. But again, this is a truck, not a passenger car. Our emission controls and our group size. And here's an example of a newer label that's a federal label. So here we have the EPA Tier 2 Bin 5 light duty vehicle, 2008 model year, California, NA. NA means it's not approved for California. This is a federal car. So on the new labels, if it's not California approved, it'll either say NA or just leave that blank or put a line dash across where you would fill that in. So this is a federal vehicle. I still have my test group, my engine size, my emission controls, and it tells me that no adjustments are needed. I mentioned that trucks, they tend to put the labels on the engine. So this is on the valve cover of the engine. This happens to be a diesel truck. And it still is going to come in and tell me it's California regulations, what year, all my emission controls, all my engine family are there. But I might have to crawl up in the vehicle to find this label on the engine. And one reason why they do this is we have engine manufacturers that sell their engines to truck builders. So there's plenty of trucks out there like Sterling, truck brands that make trucks, but guess what? They don't make their own engines. They're installing someone else's engine. And so that's one reason why the engines are certified, so they can be used in multiple applications. So here's our ECS manuals. There's two different brands. We have a Mitchell and we have a Motor. I generally at the shop will buy, as you can see, motors and Mitchells in even years and Motors in odd years, because we need to get one every year. But by having both brands, each one has things the other one doesn't. Each one has mistakes. I cannot approve a vehicle when I'm smogging it and say it's legal unless I have something in writing to back me up. So my primary emission control reference is the underhood label. My secondary reference is going to be an ECS manual or factory manuals. So even if both the manuals are wrong and the underhood label is missing, and I think that it's wrong, I still legally cannot pass the car. I have to tell the customer, go get a new underhood label. And then if the underhood label says you don't need this particular emission control device, then you're good to go. So example would be 2003 Ford Ranger 3 liters. Not all of them had an EGR valve, but both the books say they all did. So if the underhood label was missing because the vehicle had been in an accident and the hood had been replaced, I can't pass the vehicle. Even though I'm looking at the engine and it looks like it never had EGR. I've seen other ones without EGR, even though the book says they're all supposed to have it. But without that underhood label telling me I can't pass the car, I have to fail it. And then the customer has a couple choices. They can either go to the dealer and buy a label, which is what I recommend they do, or they can go see the referee The closest one to North County is Miramar, and I was working in North County. But there's also one at Southwestern and Cuyamaca. So either way, you're taking some time, making an appointment to go and tell them, hey, I've never done anything, please approve it. And they might do some research, and they have access to information I don't have, and they may be able to find the original build that it didn't have it and approve it and put a label on it. Or they may go, yeah, can't do anything for you. You need to get an under hood label because everything we have says you have to have it. Kind of a crapshoot. But the referee has the flexibility to make those decisions. As a smog tech, I do not. All I can do is follow what's in print. On the other hand, if one of these books said that they all had it, but the other one said, oh, only some of them have it. Now I've got something in writing to match up what I see in front of me. And since I have no underhood label, I can go with the book. Again, making sure that the engine never had it. And my visual inspection is good. Not that there's like a plate over where it used to be or things are disconnected or whatever. But no, this is a common thing. So an example, and I brought up this earlier, was a 99 F-Series pickup truck, 7.3 liter diesel, PCV, oxidation catalytic converter, computerized engine controls, and a malfunction indicator light. And I have a footnote right next to oxidation converter. Well, the footnote says, if manufactured before 12/8 of 98. Well, let me tell you, how many customers do you think took their catalytic converter off their 98 Ford pickup truck? A whole bunch. So what do I need to do? I need to go and I'm looking under the hood. There's our heat shields here. I'm going to look at the safety sticker, which gives me the manufacture date, right? Is the manufacture date say supposed to have it? Oh, gee, that sticker's gone too. Wow, the weight sticker's gone with the manufacture date, and the underhood label's gone. Oh, and there's a heat shield. And you want me to pass what? Yeah, people will get sneaky. And but this is why we have these books, is to give us that information and go through that. So vehicles requiring a referee label. So a referee label is a label that the referee is able to attach to a vehicle, allowing it to be smogged by any smog station. So vehicles that require a referee label are a gray market vehicle. A gray market vehicle is a vehicle that was designed to be sold in a country other than the United States. So back in the 80s, the most common gray market vehicle in the United States was made by Oldsmobile, because they were made for the Mexican market and brought across the border into Texas in large numbers. So a lot of times when we think of gray market, we think of, Mercedes, or we think of something exotic or an old Toyota or things like that. And those can also be gray market vehicles. But I've seen gray market Toyotas, Nissans, all kinds of stuff. So the simplest, it's a vehicle that is not meant to be sold in the United States. An engine conversion. So an engine conversion is not an engine replacement. There's special rules in the Smog Check manual governing, and actually Smog Check reference guide appendix E, governing the smog engine conversions. So if I'm taking out say I have a Mustang, and say it's, it's a little older, it's a 2005. And say I take out that factory 6-cylinder engine, and I put in the V8 engine that was available in the Mustang that year. And I put all the emission controls, all the computers, everything else in it, just as if that car left the factory with that V8 that was available in that body that year. That is not an engine conversion. That is an engine replacement, because that engine was available in that body by that manufacturer that year. Now, see, I take my 95 Jeep Cherokee, and I decide I want to put a Chevy LS motor in it out of a Tahoe. That is an engine conversion. I'm taking something that was never available in that body from that manufacturer and putting it into that body or that chassis. That's an engine conversion. That I would need a label from the referee for. Say I have a 92 Toyota Tacoma 4Runner. It has the 3-liter engine, and I want to put the 3.4-liter engine in it from 99. That would be an engine conversion. So even though both were used in 4Runners, both were but 2 different years, I would have to put, if I want to put that 3.4-liter in, not only would I be an engine conversion that the referee would have to give me a label for, but I would have to bring in all the OBD2 stuff, the fuel evaporation, everything else, that whole system, that whole 3.4-liter system has to be brought in. So all the OBD2 monitors, the computer, everything. So it's a whole transplant. And we see that, you know, the reason why I brought up the 4Runners, that's a popular one right now. The other one that's popular is BMWs, 92, 93 BMWs putting in like a 98 engine, OBD2 engine. Put an M54 engine in them. Better engine, dual red cam and all that stuff. And so we're seeing a lot of them do that. And so those are a couple common conversions we're seeing where, yes, same manufacturer, but that engine, even though it's a 3 Series and a 3 Series, different bodies, it was never available that year in that vehicle. That requires a go see the referee for it. That's an engine conversion. An SPCNS, a special construction vehicle, commonly called kit cars. So there's a company called Factory 5 that sells Cobra replicas. There's all kinds of stuff out there. These are really intended to be built by an enthusiast. So someone would buy the kit and spend a couple years as a hobby putting it together and building the car in the garage. And then when it's time to get it registered, they need to go see the referee and they get a referee label. Alternate fuel conversion. So if I convert my gasoline powered vehicle to CNG, LPG, LNG, or electric, I need to go see the referee. If I have a diesel and I'm converting it to biodiesel and it's 2004 and newer, I would need to go to the referee to get a label. And this really has a bigger, I mean, it has an impact on all vehicles, has a huge impact on trucks over 14,000 pounds. Because trucks over 14,000 pounds powered by CNG, LPG, or LNG are not smogged. Trucks over 14,000 pounds powered by gasoline are smogged. Right? So if I have a F550 with 17,500 gross vehicle weight rating, if it's powered by gasoline, I have to get it smogged every 2 years. If it's compared by propane or natural gas, I never have to have it smogged again. And that goes into the registration. Same with if I convert a vehicle to electric, I would never need to get it smogged again. So therefore, DMV needs to know that, and the referee is who's certifying that and putting a label on it. So here's an example of a gray market vehicle. So my first clue was not the Ford label, but the fact that I couldn't read this. Some about Mexican emissions. It does say I have a converter down here. It looks like Calico. I've got some other information, 5.4, no adjustments. But what I find interesting is the vacuum schematics in English. So apparently, you know, in Mexico, you need all this in Spanish, but PCV and manifold vacuum and that stuff, English is fine. So I find it interesting that it's kind of half translated. But clearly a clue, this car was not meant for sale in the US. When I come around inside, I notice that its kilometers per hour is on the outside and miles per hour is on the inside, just the opposite of what I would see on a US vehicle. Another clue. And lastly, here's my GVWR, my safety, my weight sticker here. I'm guessing that that's not meant for sale in Kansas. Just saying. So these are clues that we look for to see if we're working on a gray market vehicle. I like Chrysler. Not only do they put this label here, they have a big thing across it in bold letters says export only right on top of this. Another clue. So these are gray market vehicles. I use the Ford example just because a lot of times people think, exotic cars, that's a gray market vehicle. This is a gray market vehicle right here. It's a Ford. It comes down to where was it designed to be sold? Where was it meant to be sold? Here is an old style referee label. This would be affixed to the B pillar or the door where it goes against the B pillar. Bureau of Automotive Repair. I have a VIN, part of the VIN number, identification number for the label that's archived. They know what it goes to. And this is a 79 350 cubic inch Ford, federal, automatic, and it says which referee site did the certification. Then they click little X's for the different emission controls that I have to have. C&I is carburetor or injected. I got a little C there, carbureted.
Sir Brian,
Yes.
the referees, they are in Bureau of Automotive Repair or DMV, or where are they?
Okay,
I
so
haven't seen.
good question. So they are actually at community colleges. So there's one at Miramar, one at Southwestern, and one at Cuyamaca in San Diego County. And they are run under the California Community College Foundation, is who actually has the referee contract. So they work under the Bureau of Automotive Repair, and they contact the Bureau of Automotive Repair for decisions, but they're not Bureau employees. So it's kind of an interesting deal. But they have a lot more authority than a smog technician does to kind of use common sense sometimes or make a judgment call. Also, they have people in Sacramento that they're in contact with constantly, as well as area supervisors that they're in contact with that are able to make decisions that we're not able to make as smog techs. Now, the referee does not charge anything, but you have to be referred there. You have to have a reason for going there. In other words, I can't just show up there to get a free smog. The customer still has to pay the $825 for a certificate if they're getting a certificate there. But the referee services are at no charge, and that's one reason why they require people to be referred there. So, if DMV refers you there or a smog technician refers you, I pop the hood and go, oh, gray market car, I can't smog it. You need to go to the referee. I can also refer someone to the referee if the car doesn't pass smog and they've met the conditions for a cost waiver, for example, or things like that. I can send them to the referee and the referee issues the cost waiver. So there's different things the referee will do. One of the things that they will also do is if there's a dispute between a smog technician and a customer. In other words, a smog tech failed my vehicle and I don't think it should have failed. I think this is okay and the technician's wrong. I can request a appointment with the referee and the referee will go down and either pass my car or not pass my car. And sometimes it's not a matter of the smog tech being incorrect. It's a matter of the smog tech not having the authority to pass it. So for example, I had a customer that had an aftermarket catalytic converter on their car. And the catalytic converter executive order number was not in the state database that I'm required to look it up in. He was able to provide me paperwork showing that it is a legitimate executive order number and it's legitimate on that vehicle. The problem is by statute, I have to go to a particular website to get that information. So I can't look at the other information. Even though I agree with him 100%, I don't have the authority to make that decision. So I sent him to the referee. Because the manual says I have to look it up at X website, not use all available information to make a conclusion. And since they screwed up when they put the stuff into the website, they left his number off. Oops. But I don't have the authority to pass it. Go see the referee. That's what he's there for. So that's what the referees do. That's where they are. So they are great. I mean, if there's a complaint and, I failed something and you get your car failed, you say, I don't think that's a legitimate failure, or I think the person's wrong, or, what, I've already done my research and it should have passed. You can make an appointment with the referee and go do that instead of shopping for either someone that doesn't do their job and passes everything, or getting someone else to fail it when you're really not sure why you're failing. So, and the referee has authority, so they can actually, even if they don't pass it there, they can give paperwork to the consumer saying, you need to do this, you need to do this, and then any smog station can pass it as long as this is done. And then you do that, you walk in and you show that to a smog station, and that overrides things. And the station makes a copy of the paperwork, puts it in the file, and says, basically, here's my get out of jail free card. I did something that I knew wasn't right because the referees told me to do it. And it's in writing. I had that on a Jeep. I had a customer who was a jerk, failed his Jeep for a missing cat. Someone took the cat off and put a muffler in its place. Went into the factory stuff. The ECS manual is wrong. It didn't say it had it there. I went into the factory manual, pulled up a picture of the factory exhaust, clearly showed a catalytic converter there. Plus, no one puts a muffler in front of the catalytic converters on those vehicles. There's only one series of vehicles ever made that they did that. And that was an oxidation cat after a muffler on a heavy duty GM truck. So I knew it wasn't supposed to be a muffler. Go see the referee. Fine. So he went down to the referee. Referee said, nope, that's fine. You can pass it, but he failed it because he didn't want to look up the number for his cold air intake that I'd already passed. That was legal. And sent the guy back to me with a full head of steam telling me I'm wrong. It's like, no, I'm not wrong. And I actually called the bureau. I said, look, referee made a mistake. They're 100% wrong. And yet I got a customer here wanting me to pass his vehicle when I know it's wrong, but I got the paperwork from the referee saying that it's right and the referee's wrong. Bureau said, go ahead and pass it like the referee told you to do. Keep a copy of everything. You're not going to get in any trouble. Okay. No problem. Now, that being said, the person who was the referee at that time at the Miramar location no longer had a job a few months later. And I don't know if that had to do with me yelling at his boss or not. And from what I understand, it wasn't his first bad decision. But I raised a lot of static over that because it was flat out wrong. And I know the referees for all three locations now because I do training for them. And from what I understand, I wasn't exactly the only person that complained about the quality of inspection of the previous referee. Here is a newer label. So these right here, much more user-friendly. They have a barcode that we can use the smog machine to actually download the information. Here's the VIN on it. Here's all the emission controls, timing, the label number, a barcode for the label number, what site it was done at, the date. And here I have a 1990 Mazda Miata with a 1990 Ford 5-liter installed with a manual transmission, California certified. So this thing will get up and scoot. The name
Like
of the
somebody put a 5.0 in a Mazda Miata. I didn't know that.
Yeah, there was a company in Escondido actually doing these conversions. Their name was Monster Miata. And their business model, they'd figured out how to do this, and they figured out how to do it legally and get them certified. And the name of the company was Monster Miata. And they did quite a few of these conversions. I don't know the total number. But yeah, putting a Ford Mustang V8 into a Mazda Miata. Those cars would move.
Yeah.
So yeah, they fun to drive. Now, another thing I'm going to point out here is the comment section. The comment section is where the referee can put other information on the label. So, for example, we do the engine conversion on this, and we use the factory catalytic converters for the Ford 5-liter. Great. So what happens when the catalytic converter goes bad? And I want to put an aftermarket converter on it. Well, back in the day, that wasn't an issue. Today, OBD2 vehicles, it is, because now I have to match up your make, model, engine family, everything else to the catalytic converter I'm installing. Well, I'm never going to match up a Mazda Miata with that Ford engine family, right? So if I got the car certified with aftermarket converters on it, the referee would put the aftermarket converter executive order numbers right here. And then I'd know what aftermarket converters are approved for this application. Another example might be putting an Integra motor into a Honda Civic. The mistake people make is they put the Integra motor in and they use factory caps or whatever, which creates a problem later. But where I'm going is the cold air intake. So they make cold air intakes that are legal for an Integra with the Integra motor. But that cold air intake is not legal if that Integra motor is installed in a Civic, unless you put that legal cold air intake from the Integra on the motor when you go to get the motor certified by the referee, and the referee says, okay, then he'll put the EO number for that cold air intake as being approved as part of the conversion. So the mistake people make, and I understand this, I don't care if you're dealing with building inspectors or dealing with referees, your inclination is do the minimum, get it approved, and I'll do this stuff later. And that's, I think, human nature. And really what you want to do is take the stuff down and go, this is what I want. These are CARB approved for the donor vehicle. I want them on the label for the new vehicle, and that way everything's legal. And normally the referees will do most of that. And if not, what's the worst happens? You put the stock air cleaner back on, which you probably have anyways. But at least, but at least if you do get it approved, you're golden. You're golden if, you get pulled over and the cop pops your hood. You're golden when it comes to getting your car smogged. I mean, it's just done. And the mistake people make is they don't get those other things certified when they do the conversion. Here's a replacement EGR valve. So this is a perfectly legal valve, and the person who replaced it wrote the original part number on. But how's this look? Is that a problem? So that's what? Fail for defective, right? That's going to fail a smog inspection for that. How about this? How does this look? Is this okay? So my question would be is how's the gas cap going to seal?
Yeah.
Right? So that would be a visual. That would be a defective condition. Also fail smog. Here's the fuel evaporation canister. Apparently it didn't like speed bumps and opened up to let things out. So again, also defective. So those are just some of the things that I see doing smog inspections that are defective thing. Obviously some are more cheaply corrected than others. But those are all reasons why a car might fail smog. Some are very easy to correct and we can retest the vehicle right now. Other ones is like the last two require additional parts and, in order to be corrected. The state does not allow us to do any repairs, connect vacuum lines, anything after we've run the tailpipe test. So if it's a 99 and older vehicle that I've run the dyno, we do the visual inspection after the tailpipe test. And therefore, even if I just see a vacuum line disconnected, I'm by law not allowed to connect it because we've already taken the tailpipe test. And by connecting a vacuum line, I may change the tailpipe readings. So they actually require us to let the customer know, reconnect it, run in a completely a second test. That's the law. And for example, the one that's split, if I'm at a test only station, that requires the hose to be cut or replaced. A test only is not allowed to do that. They can only reconnect something that fell off. They cannot replace a hose or cut a hose back and fix it. So they wouldn't be allowed to fix it anyway. So again, so sometimes the experience that people have with smog technicians comes into, gee, the guy was really a jerk. They don't understand the legal of what we are and aren't allowed to do. And it's all in black letter law. It's real clear. Sometimes even bold black letter law. They bold it for us when they really don't want us to do something. So that's, kind of some of the experience. And I think people don't explain that well to customers sometimes. And so the customer doesn't want to believe because not everyone follows the rules or not everyone reads the manual. They read it when they got certified 20 years ago. What could have changed? And you laugh, but I get people in citation class and I'll have them, when did that manual come out? 4 years ago. Well, I brought my manual. Yeah, that manual's been obsolete for 15 years. Yeah, but it's still a manual. I can use it. No, the rules have changed. That's probably why you got the citation and you're spending 7 nights with me. And I relieved you of $500, so life's good. So that's
Brian,
yes.
where is that referee label placed? Is it under the hood and the referee puts it there himself?
The referee label, if it has one, would be in the door jamb where the B pillar is. The emission control label is under the hood. It's either going to be on the bottom side of the hood, or it's normally over right around where the radiator is on the upper core support. But most manufacturers today put them on the underside of the hood. So when you open the hood and look up, that's where you'll see an emission control label.
Okay, and the referee is on the side.
Referee will be mounted in the door jamb normally. Yep.
Door jamb.
At the B
Okay.
pillar. Yep.
Okay, thank you.
You bet. So on that note, that is the end of our emissions presentation. So that I've gone over all the questions for the PowerPoint review. So you guys got that. And then you have the test that opens up at 10 today. And I'm going to kick you guys out a little bit early, so you got some time to study or some time to do that. And then tomorrow, I got some cool stuff to show you guys, and probably let you guys out a little early tomorrow also. Sound like a plan?
Hey, real quick, there was a couple acronyms I was wondering on that last label, like back a slide or two. There's an FR. Yeah, on the next one.
Right here?
Yeah. Yeah.
FR, fuel pipe restrictor.
Okay.
Fuel pipe restrictor, that's what keeps you from putting leaded gas. So the fuel pipe restrictor is
pipe.
this right here, the fuel pipe restrictor.
Oh, okay. Okay. And the other one was EVP.
EVP. The EVP, was that it?
Yes. Yeah. What's that?
EVAP.
Oh, okay.
They left the A out. They were condensing. But no, it is truly acronym soup. And sometimes I look at them and I kind of gotta, okay, what does this have that fits more than what is that? You know, I mean, it's really, I kind of got to go the opposite way because they are so many and they tend to be so bad. Anything else? All good to go. Well, hey, everybody, good luck on your test today. And make sure you try to get your first time through today. Remember, you get 2 chances and you don't know what you get wrong or don't know until you do it the first time. So don't put off the first time. You got plenty of time to study those things so you can do it a second time and get a great grade.